I want you to just picture this. You're on your dashboard, you're looking at it while you're driving home. It's late, it's pitch black, and the temperature outside has dropped to something, specifically miserable. Let's say, what, 25 degrees Fahrenheit?
Oh, that's brutal.
It is. And you're in an electric vehicle. You've done this exact commute 1,000 times. You know precisely how much battery it takes to get from your office to your driveway. You usually get home with like 15% to spare.
But not tonight.
Yeah.
Tonight the math is just breaking.
The math is completely shattering. You look down and that little percentage, it isn't ticking down normally. It's dropping in chunks. And you do that quick mental calculation, right? Miles to home versus what you have left.
And the lines are going to cross.
The lines cross before you hit your garage. That is that specific, visceral, pit in your stomach feeling we all call range anxiety. But in the winter, I mean, it's a whole different beast, isn't it?
It is. In the industry, we actually have a different name for it. We call it cold weather range shock. Because it's not just that the battery is draining, the car is behaving like a completely different machine. The actual physics have changed because of the temperature.
And that is what we are unpacking today. We aren't just doing some generic, hey, EVs are cool episode. We are doing a proper deep dive into the specific vulnerability of lithium-ion batteries in freezing weather. The chemistry, the physics, and what happens, the logistical nightmare when you actually hit zero.
And we've got a really fascinating case study for the solution side of things. We're going to be looking at a specific local service, Sacramento Mobile EV Charging, which was founded by a guy named Dan Downey. He's basically looked at the old roadside assistance model, the tow truck, and just said, this is obsolete for the electric era.
Exactly. So the mission today is sort of twofold. We want to explain why your car betrays you in the cold. Get right into the weeds of things like internal resistance and voltage sag, and then we want to arm you with a very specific resource. If you're in the Sacramento area, we are going to tell you exactly who to call so you don't end up on the side of the highway, frozen.
It's basically a survival guide for the modern driver.
Let's start with the science, though, because I think most people have this sort of vague idea that, batteries don't like the cold. But why? I mean, is the electricity freezing? That doesn't seem right.
No, the electricity isn't freezing. To really get it, you have to stop thinking of a battery like a fuel tank. A gas tank, that's just a bucket. A battery is it's a tiny chemical factory. Inside every single one of those lithium-ion cells, you have ions swimming through a liquid, an electrolyte, between the cathode and the anode.
Okay, so there's traffic.
There's traffic. And at, say, 75 degrees, the electrolyte's nice and fluid. The ions can just zip back and forth, no problem. But as the temperature drops, that electrolyte, it starts to thicken up. It gets viscous.
So the commute for the ions gets a lot harder.
Think of it like this. Are you swimming in water, or are you trying to swim through like cold maple syrup? It takes so much more physical effort for the ions to move. In electrical terms, we call this internal resistance. And as the temperature plummets, that resistance just spikes.
Which means the energy's there, it can't get out.
It's really struggling to get out. And this leads to a phenomenon called voltage sag. Now, this is the part that really tricks the driver. Your car's computer, it estimates your range based on voltage. When you hit the accelerator in the cold, all that resistance makes the voltage drop temporarily. The computer sees this sudden drop and it panics. It thinks the battery is way emptier than it actually is.
Oh, wow.
So it drastically recalculates your range downward.
So the car is, in a way, it's gaslighting you.
I mean, yes, in a way, but it's also trying to protect itself. See, you try to force a really high current through a cold battery, you risk something called lithium plating. And instead of the ions embedding nicely into the anode, they plate onto the surface as metallic lithium.
And that's permanent.
That is permanent damage. It degrades the battery's capacity forever. So the battery management system, the BMS, it deliberately throttles your power to stop that from happening.
Okay, so that explains why the car feels so sluggish. You stomp on the pedal and you just don't get that classic EV snap.
Correct. The BMS is basically saying, hey, I cannot give you full power right now without hurting myself. So you've got higher resistance, lower voltage, and throttled power.
But hold on, that's just the battery side of things. I feel like there's another half to this equation. Because when I'm in my old gas car and it's freezing, I just crank the heat. The engine's already making heat, so that warmth it's basically free, right?
Exactly. An internal combustion engine is incredibly inefficient. It turns most of the gas you put in into waste heat, not motion. In the winter, you just harvest that waste. But an electric motor, It's something like 90 to 95% efficient. It produces almost no waste heat.
So to heat the cabin.
You have to make that heat from scratch.
Huh.
And if you have an older EV,
Mm.
or maybe a cheaper model that uses what's called resistive heating, which is basically just a giant space heater coil, you're drawing a massive amount of current directly from that battery just to keep your feet warm.
Okay, so you're draining the battery to move the car through what you called molasses, and you're draining it even faster just to heat the air inside.
It's a huge parasitic load. I mean, you can see your energy consumption jump by 30, 40, sometimes even 50% just from running the climate control. And that is why the range on your dashboard just enters a free fall.
Okay, so let's play this nightmare out. You didn't do the math right, the cold caught you by surprise, you're on the shoulder of the freeway, the car is dead, it's a brick. What do you do?
Well, the reflex for everyone is to call a tow truck,
Yeah.
AAA,
Yeah.
or whatever roadside assistance you have.
Sure, that makes sense. That's what we've done for 100 years.
But this is where the EV architecture just really complicates things. You can't just put most EVs in neutral and simply drag them away.
No, why is that? If the wheels turn, they turn. What's the problem?
It's not that simple. In a gas car, neutral physically disconnects the transmission from the wheels. In a lot of EVs, the motor is always mechanically connected to the wheels. So if the wheels are turning,
The motor is spinning. Okay, but if the car is off, who cares?
the laws of physics care. A spinning electric motor, it acts as a generator. It creates electricity. We call it back EMF, back electromotive force. And if the car is dead, all the systems that usually manage that electricity, the inverters, the battery contactors, the cooling pumps, they're all shut down.
So you're just generating electricity with absolutely nowhere for it to go.
Precisely. You're generating high voltage and a lot of heat inside the motor and the inverter, but with no active cooling. You can literally fry the capacitors in your inverter or overheat the stator windings just by towing the car for a few miles.
That sounds incredibly expensive.
Oh, it is.
Yeah.
We're talking thousands of dollars in drivetrain damage.
In fact.
And that is why the owner's manual for almost every single EV says flatbed towing only.
And there's the bottleneck.
Right. Just think about it. It's a snowy night in, say, Sacramento. There are accidents everywhere. The demand for tow trucks is through the roof. But you can't use just any tow truck. You specifically need a flatbed.
So you're left waiting.
You're waiting for hours. And when the driver finally shows up, they have to winch your dead car onto the bed. It's a slow, cold, miserable process.
Oh.
And this is the part that drives me crazy. Where does he even take you?
To a charger, I assume.
Right. He doesn't take you home. He drops you in some random parking lot that has a charger. So now you've waited 3 hours for the tow, you've paid for the tow, and you're sitting in a dark parking lot at 2 a.m. waiting another hour for the car to charge up.
It's a complete logistics failure. You've solved the location problem, but you haven't solved the energy problem at all.
That's the perfect way to put it. And this brings us right to our case study. This is exactly where Dan Downey and Sacramento Mobile EV charging come into the picture.
I love looking at businesses that spot a gap just like this. So Downey basically looked at this whole flatbed nightmare and asked, wait, why are we moving the car at all?
It's that classic logic, right? If the mountain won't come to Muhammad, you bring the energy to the car.
So talk to me about the actual hardware. I mean, we're not talking about a guy showing up with one of those portable power banks you use for an iPhone.
Oh, no. This is a robust mobile generator setup. It's a van, and it's equipped with a high-capacity generator that's capable of delivering a level 2 or even a fast charge directly to the vehicle right where it sits.
Okay, I have to play devil's advocate for a second. Is it actually fast enough? I mean, if I'm stuck, I don't want to sit on the side of the road for 4 hours while some generator just hums away.
And that's a valid question. Look, it's not a supercharger. You're not going to get a full battery in 15 minutes. But you have to remember the goal here. The goal isn't to get you to a 100% state of charge. The goal is what we call rescue charging.
Right. You just need enough juice to get home.
Exactly. You need maybe 20 or 30 miles of range. With the setup that Sacramento Mobile EV charging uses, you're looking at, maybe 20 to 30 minutes of charging to get you safe.
Which is probably less time than you'd spend just waiting for dispatch to even find a flatbed driver who's willing to come out in that weather.
Oh, significantly less. And the key differentiator, the thing that really matters here, is the no towing policy. By using a service like this, you completely eliminate that risk of back EMF damage we were just talking about. Your wheels never leave the ground. Your drivetrain is never stressed.
It feels like a much cleaner solution, less violent to the car.
It is. And it's just a better user experience. Instead of your car being held hostage on the back of a truck, you're in control. The second that cable is unplugged, you just drive away.
I do want to talk about the irony for a second. We're almost certainly talking about a gas or diesel generator charging an electric car. There are going to be purists out there who say that defeats the entire purpose.
Oh, absolutely. And on a macro level, sure, we want the whole grid to be green. But in an emergency situation, resilience trumps purity every time. If you are freezing on the side of I-5, you do not care where the electrons are coming from. You just need them in your battery.
It's triage.
It is.
Yeah.
And honestly, it's a brilliant business pivot. We see these traditional services like AAA, they're struggling to adapt to this. They are massive ships that turn very, very slowly. They have thousands of tow trucks. They don't have thousands of mobile charging vans. Not yet.
And why is that? Is it just the cost?
It's capital inertia. Their entire business model for decades has been built around tow to repair shop. But EVs don't break down that way. They don't blow head gaskets or snap timing belts. They run out of power. A company like Downey's, Sacramento Mobile EV Charging, is agile enough to recognize that the commodity itself has changed. The service isn't towing anymore, it's energy delivery.
Energy delivery. I like that. That sounds like the future.
It really does feel like it, doesn't it?
Okay, we promised we'd be specific for our listeners in the region. So if you're driving an EV in or around Sacramento, this is the part where you pull over safely, of course, and take a note. Because when that panic sets in, you won't want to be scrolling through forums trying to find this info.
Right. This is a real operational service available right now. The company name again is Sacramento Mobile EV Charging.
And the number?
It's 916-826-9410. I'll say it again because you should probably just save it in your phone as EV Rescue or something. It's 916-826-9410.
And they do have a website, sacramentomobileevecharging.com. But let's be real. If you're stranded, you're making a call.
100%. And, looking at Dan Downey's operation, it really puts a spotlight on this weird gap in our infrastructure. We've spent billions of dollars building all these stationary chargers, but we have very little redundancy for when things go wrong between those chargers.
It's like the last mile problem, but for electricity.
It effectively is. And for the user, the psychological benefit is huge. We started this whole conversation talking about anxiety. Anxiety comes from a lack of options. Just knowing that a service like this exists, that you can make one phone call and have a power plant come to you, that cures the anxiety.
It turns a potential disaster into, what, a mild inconvenience?
Exactly. Instead of my entire night is ruined and my car might be broken, it becomes, okay, I'm going to be about 30 minutes late.
I want to zoom out for just a second before we wrap up. We're seeing this in Sacramento with Dan's company. Do you think this is where the whole industry is headed?
I think we're looking at a transitional era. I mean, eventually, maybe battery density doubles and this all becomes a non-issue. Or perhaps the roads themselves get electrified. But for the next decade, absolutely, we're going to see a huge shift from centralized fueling, going to the gas station, to decentralized charging.
Meaning the fuel actually comes to you.
Think about it. We get our food delivered to us. We get our movies streamed to our house. Why are we still driving to a specific concrete island just to get our energy? Services like Sacramento Mobile EV Charging are basically DoorDash for electrons.
That is a very catchy way to put it.
But it makes sense, right?
Yeah.
If you can charge while you're parked or while you're asleep or even while you're stuck on the side of the road,
Yeah.
the vehicle just becomes infinitely more usable.
But until that utopian future arrives where, I don't know, drones are dropping batteries into our sunroofs.
We have to deal with the physics we currently have.
Which means
You have to respect the cold. If you own an EV, you need to understand that 30 degrees isn't just sweater weather for your car. It's a serious performance-degrading event. You should precondition your battery while it's still plugged in at home. Use your seat heaters instead of the main cabin heater if you can.
and have a backup plan that doesn't involve a hook and a chain.
Correct. Avoid the tow trap. If mobile charging is an option for you, you take it every single time. Your inverter will thank you for it.
So the big takeaways from the deep dive today. First, the cold thickens that electrolyte and causes voltage sag. Your battery isn't broken, it's just really struggling against resistance.
Second, towing an EV is just fraught with mechanical peril because of back EMF and the fact that most don't have a true neutral gear.
And third, if you happen to be in the Sacramento area, Dan Downey's Sacramento Mobile EV Charging is the fix. No towing, just juice. What's that number one last time?
It's 916-826-9410.
It's fascinating how a little bit of knowledge about chemistry and one good phone number can completely change your entire winter driving experience.
Knowledge is power, literally, in this case.
Thanks for listening to The Deep Dive. Stay warm out there and keep those electrons flowing.
Safe travels.